it's instructive to graph these functions, the 10 to the x function and the log x function, to see how the graph of a function and its inverse compare. Notice that we've got a lot of big numbers on these graphs. We got numbers like 100 here and 100 here, and small numbers, 0.01 here, 0.01 here. It's not going to be convenient to graph those on the same graph that we use for -1, 0, 1, 0.11, 10. We're going to kind of confine the graph to these middle numbers in this column, or in this table and in this table. So note that 10 to the x, we've got -1.1, 0, 1, 1, 10. Here we have 0.1, -1, 1, 0, and 10, 1. You should pause the playback right now and sketch a graph of the 10 to the x function at these 3 points and the log function at these 3 points. And then we're going to look at the graph. Here is an approximate graph of y equals 10 to the x. At -1 we have 0.1, -1, 0.1. We have the 0.01, which I haven't labeled, and the 0.110, which I haven't labeled. These are on the graph of y equals 10 to the x. Now what do we get when we reverse the coordinates of 1, -1? Well, we get -1, 1. That point is right here. And actually, I'm seeing that I've completely screwed up the labeling of this thing. This should be -1.1, and this should be 0.1, -1. When I wrote the coordinates here, I was just careless. So let's be real sure about that. Okay, it's -1.1 and 0.1, -1. And I apologize for the confusion. Anyhow, when we reverse these coordinates, instead of being near the x-axis, now we're near the y-axis. Okay? When we reverse the coordinates of 0, 1, we get 1, 0. Reverse the coordinates of 1, 10, we get 10, 1. In each case, we can think of the relationship between the points that are connected by these dotted lines as being a reflection across the y equals x line, the line that moves at a 45-degree angle if we use a consistent scale. And my scale here isn't real good. I've not drawn this all that well. But each of these lines connecting the point and the reversed coordinate point should cross this line at a right angle, as I've indicated here. And the distance on one side should be the same as the distance on the other. I've misplaced this point. This point should be over here much closer. And this point's probably out too far also. But if you draw it carefully, you'll see that, again with equal y and x scales, you'll see that the distances are the same and you do cross at a right angle.